Hi, hello everyone. In this video, we discuss about application of differentiation. In optimization, there is optimum value problem. Right, so this is the step that you have to follow in order to solve the question. So first, determine the function to be optimized. Secondly, differentiate the function. Third, find the value of s where f prime equals to 0 or f prime does not exist, but usually we use f prime equals to 0 only, very seldom in cases does not exist. And then number 4, use the first or the second derivative test to determine the maximum minimum relative. Right, so usually for optimization cases, usually we'll use second derivative. First derivative usually for the graph or function. Okay, next. Using the chain rule, I think the chain rule is not a must in this case because chain rule is a must in rate of change. So in rate of change, yes, you have to use chain rule, but for optimization, it's not necessarily using the chain rule. In other hand, for optimization, you have to obtain another equation so that we will have equation in single terms only. Okay, so later on when we discuss the example, I'll show the cases for this situation where the importance for find the other equation in order to make a single terms equation. Okay, right, so now look at this example. Right, from the lecture notes, I already skimmed out and choose the most relevant example to discuss in this video. So if you're interested to learn about more difficult applications, so I suggest you find the partial questions books. So for this video, I just discuss the very basic example so that you have the basic understanding on how to use to solve the optimization cases, right? Right. So in this example, an open board with a square back is based from the square face of cardboard with dimension 12 cm of each side. So actually this is the cases, cardboard. Okay, so the cardboard is 12 times 12, right? And then a square will cut out for each corner in cardboard. So this is a cut, we cut each corner, so we have 4 corners, so we cut 4. And then we turn up to form a box. So this is the box that you will turn out. So look at the arrow. So this is the box on the right here. Okay, so this is the box. So as you can see, we already cut X on both ends. So this is X and X. So the length of 12 already reduced by 2 times X. So that's why, as you can see, the length of the box here, 12 minus 2X. And the X, when we fold, it will come the height. Okay, the height is X. So the volume would be 12 minus 2x for each side, length, width, and then the height will be x. So that's the volume. So look at the solution here. So as I said just now, the dimension, length, width same, that is 12 minus 12x minus 2x, and then the height will be x. Okay, So we expand in order to make easier for us to differentiate later. So we expand. So we got 144 minus 48 plus 4x squared when we expand the same the length and width. And then we multiply with x. So this is the volume that in terms of x, that is 4x cubed minus 48x squared plus 144x. And then we differentiate to get dv dx. So 12x squared minus 96x plus 144. And then as usual, at maximum, remember you have to find the maximum value. So I just put at maximum. So at maximum, dv dx equals to 0. So our first derivative we equate with 0. So we got 12x squared minus 96x 100 plus 44 equals to 0. And then we know each term can be divided by 12. So we can simplify to get x squared minus 8x plus 12. So we know this one we can factorize easily, x minus 6, x minus 2. So that we got the value of x is 6 and or 2. So which these two value will get maximum? So in order to determine this one, so you have to find the second derivative. So this is the second derivative. So we got 24. 12 times 2, 24x minus 96. And then we substitute these two values into the second derivative. So first we substitute x equals 6, we got 48. So 48 is greater than 0. So for second derivative, if you got positive, it will be the minimum lah. So this is not we want. So let's try another one, x equals 2. So we got negative 48. Yes. If the negative, the conclusion will be maximum. So this is the value that we need. That is, we can put the conclusion that to get V maximum, we need x equals 2. Okay, so don't forget this conclusion in order to make sure you didn't lose a marks. And then also here, don't forget, you have to mention greater than 0 and then minimum or less than 0, they will get maximum. So don't forget this conclusion in order to avoid losing a marks. Okay, so this is the first example. Oh, by the way, don't forget the question asks about dimension. So don't forget, rewrite again. So the dimension, length times width times height. Okay, this one the dimension. So we just substitute the value of x, that is 2. So 12 minus 2 times 2. Also 12 minus 2 times 2. Then we get the dimension would be 8 times 8 times 2. Okay, remember the dimension we have to right in front of this one. Length times width times height. Okay. So be very careful with this example. So that's why it's very important for you to read the question very careful. The question asks about dimension when V maximum. Okay. So don't forget the final answer must be in terms of dimension. Okay. Right. So now we move to the second example. So this second example, there's a diagram over there. So we have a rectangular inscribed. Inscribed means inside. So the rectangular is inside the semicircle. So given the equation of semicircle, so this is the equation of circle. Equation of circle. So later you will learn about this equation of circle in second semester. Right. Denoting OQ equals to x, show that the area of rectangle is 2x times 25 minus x squared. And then for question B, when x varies, find the value of x such that the area of rectangle is maximum and determine its maximum value. And then C, calculate the perimeter. So remember the first one, show. Second one, area maximum. And then third, the perimeter. So now look at the first one. So to show, right, so as you can see, I already label the length OQ is X, so that the length RQ would be Y. So the area of rectangle, so we know the area of rectangle X plus X, so 2X times Y, length times width. So we got 2XY, okay, for the area. And then remember, as I already mentioned in the previous slide, so you have to figure out another equation to make our equation in single terms only. So as you notice over here, our equation in terms of X and Y. So we cannot differentiate at this point because we have two variables X and Y. So we have to change Y in terms of X. So in order to do this, you have to find out another equation to relate Y with X. So that's why we use this equation of circle. So we use this equation of circle. So we can rewrite Y in terms of X. That is Y equals to square root of 25 minus X squared. So with that, we can substitute this Y into our equation of area. So with that, our equation of area would be 2x times sec of 25 minus x squared. That is from the another equation. So with that, we can show for question A. Okay, so that's for question A. Right, next for question B. So for question B, okay, just now we already show from A, that is area 2x times 25 minus x squared. So from here we need to differentiate. Remember, as I told you before, since we already make a single term on the right hand side, then we can differentiate. So A in terms of x, so differentiate would be dA dx. Before that, as you can see over here, since we have two terms, 2x and also sec 25 minus x squared, so make sure you have to use product rule. So you know u is 2x, so u prime would be 2. And then sec 25 minus x squared is v, so differentiate v prime would be, so as you can see, I already simplified, so we got negative x over sec of 25 minus x squared. Right, so that one for v prime. So with that, we can use the product rule. So dA dx equals to, so u v prime, okay, so we know it's u, this one is v prime plus v u prime, right? And then we notice that we have similar terms here. So the smallest one is this one, so we factor out this one. And also we have 2 over here, so 2 also we factor out. So it will be like this, 2 over sec 25 minus x squared. So after we factor out, we got x times negative x, so negative x squared. So negative x squared we bring back here. And then here, since we factor out over sec, so this one times another sec, that's why it will become, we can eliminate the sec, 25 minus x squared. So 25 minus x squared, so this one is negative, so I put at the back. So negative x squared, then we can simplify. So 25 minus 2x squared. Okay, so that would be our dA dx. So this is already the simplest form, so no need to simplify anymore. Okay, so next, what we do? After we differentiate, remember we have to, right, next at maximum. So we write dA dx equals to 0, and then our first derivative we equate with 0. Okay, then we bring sec 25 minus x squared to the right hand side, so 0 multiplied with that will become 0. Also 0 divided by 2 also 0, so that we can simplify and we get 25 minus 2x squared equals to 0. Also, after we bring down all the coefficients, so we get x squared equals to 25 over 2. So we know generally square root will be plus minus, but since x, the dimension must be greater than 0, so we take only the positive value. So make sure you write a notation x greater than 0 here, so that we can conclude that x equals to 5 over 2. Or if you press in your calculator, they already rationalize for you, that is 5 2 over 2. Okay, so this is the value of x. But remember, do not take this value straight away to find the maximum area, because we still have to prove that this value will get maximum. So remember, you have still to find the second derivative. So remember, this is the first derivative. Previously I already expand the two be above here, so I already expand and rearrange, so the ADS should be like this. Okay, I write in this form so that we can easily find u and v prime. Okay, so we know above 50 minus 4x squared is u, and then 25 minus x squared is v. So as you can see below there, I already find out u prime, that is negative ax, and then v prime, after we differentiate everything, that is we get negative x over 25 minus x squared. So we apply in the quotient rule to get the second derivative. So remember quotient rule, v u prime minus u v prime over v squared below here. Okay, so as you can see, I don't simplify. Why? Because in this case we already know the value, right? So there are no extra mark if you want to simplify. So don't waste your time with the simplify. We just straight away substitute the value of x 5 2 over 2 into our second derivative, and then straight away we got the value of second derivative is negative. So make sure to write the value of that. So to show that you calculate that value, so I already show here the value is negative 5.13. So obviously, if the value is negative, then we will get the conclusion that is maximum. So don't forget to write down the conclusion less than 0, that will get maximum. Then after that, we can conclude that a maximum when x equals to 5 2 over 2. And then don't forget the question ask about the maximum area. So substitute into the formula of area. So remember from A that we already show earlier. So substitute the value of s into this equation. So that will get the value of A is 25. So that will be our answer for part C. Okay. So that's all for the second example. Oh, but I think it's not yet, or that one or still the second question. We still have the third question. So the third question is to find the perimeter. Okay. So before we find out the perimeter, since we already find the value of x, don't forget to find the value of y. Okay. So we find the value of y, so substitute into the equation. So we find out that actually, if we square root 25 over 2, we got 5 2 over 2 also. Remember, this is the value of x. Okay. So seems that the value of x and y is same. Okay. So our perimeter, so in general, without knowing x and y is equal, so look at the diagram here. So this is the perimeter. So the perimeter should be 2 times 2s, because this is xx. Okay, PQ is SS, and then RS also 2X, so 2 times 2X plus 2Y, okay, RQ and also PS, so 2 times Y, so we got 4X plus 2Y, and substitute Y also equals to X, so plus 2X lah. So that the parameter would be 6S, and then substitute the value of S, that is 5 sec 2 over 2. Then we can conclude that the perimeter is 15 times sec 2. If you change to decimal, you will get the same answer as shown below here, that is 21.2 for the perimeter. So this one, or also in the third form, both are acceptable in this case. Okay, so since I already eliminated a few examples that I think is not suitable in the lecture, so I replace with this equation instead, so that we have another question to discuss in the lecture. So look at this extra example here. So it is cylindrical steel container of volume 250 pi meter cubic is to be constructed by using, it's not do, it should be by using the same material for the top, bottom, and lateral side. So lateral means the side. Find the dimension of the container that will minimize the amount of material used. So remember the formula for surface area and also volume of cylinder in your secondary school. The value would be, yes, pi r squared h. So pi r squared h already given, the value is 250 pi. Do we need to differentiate this one? Actually not. The purpose for this equation is only to relate h with r. So as you can see here, I put h as subject, so we can express h in terms of r, that is 250 over r squared. So later on, the equation that we need to differentiate actually the equation of surface area. So remember the formula for surface area for cylinder? Right, the formula is 2 pi r squared plus 2 pi r h. So remember, the h here we already replaced with this one. So h would be 250 over r squared. So here r we can cancel out r here, and then we can expand 250 times 2 is 500 pi. So we got 500 pi over r. So this is the equation of area. Then we need to differentiate this one. So differentiate will get dA over dr. So dA dr, so 4 pi r minus 500 pi over r squared. So this is dA dr. And then don't forget, for maximum or minimum, you have to equate dA dr with 0. Okay, so I already stated that at minimum dA dr equals to 0. So that our first derivative, previously we equate with 0. So we know we have over r squared, so this one we multiply also with r squared. So we got 4 pi r cubed minus 500 pi. So this r squared we bring to the right hand side, so 0 multiply with anything, we also got 0. So that we can eliminate r squared, so we got r cubed. So we can eliminate, as you can see here, we already eliminate pi, and then we rearrange to get r cubed. So r cubed is 125. So square cube root of 125, therefore the value of r is 5. So after we find out the value of r, we can find the value of h. Remember, relation between r and h. So 250 over r squared. So substitute the value of h, the value of r. So the value of H would be 10. So this is the value of R and H. But our mission is not done yet, because we still don't know whether this value of R and H will get minimum or not. So remember, you have to do second derivative. So second derivative, as you can see there, so we differentiate again. So we got 4 pi minus 500, so R squared. So we bring above the negative 2, so multiply with negative 2. So the power will be negative 3, so bring negative t below back. So we got R squared, R cubed below here. So negative negative, so we got positive 1000 pi over R cubed. Okay, so that will be the second derivative. And then don't forget, we have to substitute the value of R in the second derivative. So when R equals to 5, so sub R 5, so we got 12 pi. So 12 pi is a positive value. So remember, you have to mention the positive value is greater than 0. So the greater than 0 would be minimum. Then after that, we can conclude that R equals to 5 and H equals to 10 when A is minimum. Right? So that's for the extra example here. And that would be the last example for our video today. So thanks for watching, and remember, for the next video we discuss about rate of change. So remember, after this, solve the question in the tutorial book, so make sure you have a better understanding about optimization. So until then, thank you, bye bye.